Okay, we have worksheet 5.3 now, so we're going to take a look at the next part here. So for this worksheet, we're going to focus on the idea of what isotopes are. Okay, so now, first things first, what are isotopes? Do take note, they are atoms. Think of it plural. So there must at least be two atoms. Okay, and these two atoms are of the same element. Okay, two atoms of the same element. For example, oxygen. These two atoms, both of them oxygen. Same number of protons, because they are both oxygen, so both of them, the proton number will be 8. Same number of electrons, because they are atoms, okay, they are electrically neutral, that's why the proton and electrons are the same, but different number of neutrons. So if you look at a periodic table, this is the one that you'll see, oxygen 816. Now an isotope of oxygen, it could actually be oxygen 188. Why? If you look at in terms of the PEN, okay, the proton, electrons, and neutrons. So for this, P is 8, E is 8, number of neutrons, N is equals to 8 also. Okay, for this atom of oxygen, number of protons is 8, number of electrons, because electrically neutral is an atom, proton and electrons are the same. In terms of the neutrons, take the bigger number minus the smaller number, neutron is 10. Hence, these two oxygen atoms are isotopes because it has the same number of protons, same number of electrons, but different number of neutrons. So isotopes are atoms of the same element with same number of protons, same number of electrons, but different number of neutrons. So in question 2, it says the particles listed below, there are two sets of isotopes. Which particle below are isotopes? So do take note, first thing first, they must be atoms of the same element. If they are the same element, means must have same number of protons. Okay, so if I look at this, you know, A and G is a pair. So I know A and G is a pair because 12 protons, same element. I know they are the same element. Next one, D and I. Sorry, D and I. Wrong, sorry, not D and I. E and I. E and I are the same element. And last one, D, F, and J. D, F, J are also the same element. Now, for them to be considered as isotopes, do take note, they must have the same number of protons, same number of electrons, same number of, but different number of neutrons. Okay, so maybe let's erase, let me just use the same color coding first. So for example, A and G both have 12 protons, so I circle in red. E and I, okay, is the next set. And the last set I will use green is actually D, F, and J. So let's focus on the red one first. So for the red one, okay, I know A and G. I'm comparing A and G now. So same number of protons, same number of electrons, different number of neutrons. So I know A and G is the first set. Why? They have same number of protons, but different number of neutrons. To be exact, it's same number of protons and electrons. Okay. Next one, let's compare set E and I. E and I, let's use the orange color one. Orange color. So this orange. So E and I, same number of protons. Oh, different number of electrons. So therefore, E and I cannot be considered as isotopes. They are not isotopes. So yeah, instead of saying isotopes not, let's put not isotopes. Huh? Okay, not isotopes. Why are they not isotopes? Because isotopes also have same number of protons, same number of electrons. But you can see electrons here are different, so they are not isotopes. The last one is the green one. Okay, all have one proton. All of them have one electron, so same number of protons, same number of electrons. In terms of neutron, 0, 2, and 1. So yes, this is correct. This is also isotopes D, F, and J. So DF and J, they are the second isotope set because the same number of protons and same number of electrons, but different number of neutrons. So D has 0 neutron, F has 2 neutron, J has 1 neutron. Now just a little top up here. Okay, if you look at question 3, it's really about thinking through how to write the chemical symbol for isotopes. So question 3 says hydrogen exists as 3 isotopes. 2 of these can be shown as deuterium, 1H2, tritium, 1H3. Now do take note, deuterium and tritium are both hydrogens. It's just a different form of hydrogen. Sometimes you'll call deuterium, another name we'll give deuterium is actually hydrogen 2. Okay, hydrogen 2. Tritium is also known as hydrogen 3. Okay, so the 2 and 3 coincides with the nucleon number. So explain the difference between the atomic structure of the 2 isotopes. So if you look at this here, remember isotopes also have same number of protons, same number of electrons, but different number of neutrons. So for deuterium, it actually only has 1 neutron, because 2 minus 1. Tritium has 3 minus 1, 2 neutrons. So they have different number of neutrons. Deuterium has 1 neutron, while tritium has 2 neutrons. Okay? So next one, they ask you to write the symbol for other isotope of hydrogen. So now, hydrogen, because they are hydrogen, the proton number will definitely be 1. The chemical symbol will definitely be H. What makes the difference is actually the top number here, the nucleon number. So because of the different number of neutrons, this number here will be different. So the example given here, they have actually written 1H1. So this is a hydrogen with a nucleon number of 1. If you want to look at it, actually this is a hydrogen with 0 neutron. Some of you might say, "Sure, can I write this?" Yes, you can, because this is a hydrogen with 3 neutrons. Now, I just want to say one thing. Do take note that if you write 100 over here, chance of it being wrong is quite high. Do take note that it is quite unstable to have a lot of neutrons, but a lot lesser protons and electrons. Okay, so 3 neutrons are still acceptable, but if you were to write something like 100H1, this is like saying that I have 1 proton, 1 electron, but I have 99 neutrons. Now, this gives a very unstable hydrogen, so this will never exist. And last one, in terms of atomic structure, what do 3 isotopes of hydrogen have in common? Same number of protons, same number of electrons. 1 proton, 1 electron. Okay, so that's all for worksheet 5.3. That's all.